Okay, this is another balancing chemical equation, but this one's got a lot going on. The first thing that I notice is that this one has a lot of polyatomic ions in it. Here's phosphate and here's phosphate. So I definitely want to make sure that I keep track of how many phosphates there are, not individual phosphorus and oxygens. The other thing I notice is that there's hydroxide on one side, but not on the other side. On the other side, there's water. And this is a little trick, that if you see that hydroxide on one side and water on the other, if you change water to HOH and balance the hydroxides as their own groups, that'll make things easier. And balance out the lone hydrogens as their own groups. So what I'm doing here is I'm sort of underlining the 4 different elements or compounds that I'm going to balance. So I'm going to balance the blue hydrogen, the orange phosphates, the red magnesiums, and the green hydroxide groups. Okay, so first thing we're going to do is take an element inventory. Blue hydrogen on the left, there's 3. Blue hydrogen on the right, here it is, there's only 1. Orange phosphate, on the left there's 1, and on the right there's 2, right? We see that subscript of 2 there. Red magnesium, on the left-hand side there's 1, on the right-hand side there's 3. Again, look for the subscript. And green hydroxides, on the left there's 2, and on the right there's 1. So I got a lot of balancing to do here. So start using some coefficients. If I put, right, I look at hydrogen, just look at the first row of my table, how many, what number I should say, do I need to multiply 1 by to get 3? And that's a 3. So I put that coefficient there. That makes this number now a 3. My blue hydrogen are a 3. That makes my green hydroxides a 3. So now let's move to the next one, phosphates. I notice that I have 1 on the left and 2 on the right. So what number do I need to multiply 1 by to get 2? That's a 2. So I put a coefficient of a 2 out front here. That changes that to a 2, but wait a second. That changes my blue hydrogens to a 6. Okay, that's fine. I can undo that by changing this coefficient into a 6. That changes my blue hydroxides to a 6. It also changes my blue hydrogens to a 6 and my green hydroxides to a 6. Now let's look at magnesium. There's 1 red magnesium on the left, there's 3 on the right. So if I put a coefficient, right, what number do I need to multiply 1 by to get 3? That's 3. That changes this to a 3, the red magnesium's to a 3. And 3 times 2, it means that my green hydroxides become a 6. And now everything is balanced. If I go back and double check, 6 hydrogen on the left and 6 hydrogen on the right. 2 phosphates on the left, 2 phosphates on the right. 3 magnesiums on the left, 3 magnesiums on the right. 6 hydroxides on the left, 6 hydroxides on the right. Okay, you can use highlighters for these instead of where I underlined here to make sure that we are looking at the polyatomic ions and balancing those as their own group.